네, 저는 하산이라고 합니다. 저는 한국에 5년 전에 왔어요. 그것 때문에 조금 한국말 할 수 있어요. 네, 네, 네. 그 일단 발표는 영어로 할 거예요. 네, 저 넥스트리밍이라고 회사에 다니고 있어요. 우리 회사에서 동영상 서비스 넥스트플레이어 SDK의 제품을 개발하고 있어요. 그거 말하면 엑소플레이어랑 비슷해요. 근데 따로 만들었어요. 그럼 오늘은 제가 엑소플레이어 소개하고 그 다음에 조금 데모 코드 보여줄게요. 네. The contents of my talk will be media player, playback and Android, ExoPlayer overview, and some of the adaptive media playbacks, protocols, some demos, and about content protection. So some of the terms I will use in my talk because I don't have much time. Dash, dynamic adaptive streaming over HTTP, HLS, HTTP live streaming, DRM, digital rights management, MPD, media presentation description, and ABR, adaptive bitrate streaming. So I will just use the short terms. So until now, if you have tried the media playback in Android, you will probably be using media player and surface view. But you can also use video view. But there's a new ExoPlayer that was open sourced by Google recently, and I think that's a good option also. But I will tell you like how many advantages it has. So ExoPlayer is an open source application level media player, because when we talk about the Android media framework, you go very low until media codecs and media extractor APIs. So those are very difficult for the application developer, because you need someone who knows codecs, who knows buffering, networking. But the ExoPlayer just hides all that complexities from you. And it supports Dash, which is very popular for streaming. I give you an example about Netflix. For example, they use Dash and HLS and smooth streaming made by Microsoft and some encryption. So what are the advantages of ExoPlayer? It supports all the famous and popular standards like Dash, HLS, and smooth streaming. It also supports DRM, protected content, so you can protect your content. It is customizable. They provide the default implementation, but you can write your own. For example, you want to support some special media codec, you can just write your own and plug it in. It is easily updatable because Google is regularly updating it. So if you go to the GitHub site, you will see that every now and then they release some major updates. And this is one of the major advantage, because I work in a streaming company, so we have more than 200 devices, Android devices, and the few device specific issue is a big advantage. So if you think that your streaming protocols works on across all devices, that's a big advantage. So I think ExoPlayer provides that. But there is a drawback. Drawback is that for Korea it's okay, because Korea has all new phones. Many people will be using all the latest phones. So these ExoPlayer, if you want to take full advantage of it, you have to use Jelly Bean onwards. From there onward, you can use media codec APIs and some of the encryption APIs. So if I show you the component diagram, this is the Android framework. This is very low level. It's media extractor API. From Jelly Bean onwards, it's open. You can use the API. So, and then there is the media codec API, which provides decoding and renderer. On top of that, there's ExoPlayer. So ExoPlayer has video, audio, and text renderers. And also, you can make your own renderer. For example, I see some Korean television. So they put some like layering on top of that, some emoticons and those kind of things. So you can make your own renderer for that. And it has the default sample source implementation, which basically gets the media. Like media is basically like it is described by a manifest file I will show you later. And it just gets the chunks and then makes samples and provide to the renderer. And renderer can directly talk with media codec APIs for decoding. It decodes both video and audio. And the audio track basically allows it to play the audio. So these are the interfaces which ExoPlayer provides. Track renderer, there are like basically three kinds of renderers: video, audio, and text. Text for subtitles. And there are sample sources. So the first one is basic. It's for playing the MP4 format. And then there is chunk sample source for dash and smooth streaming. And the last one is HLS sample source. And data source is more like loading the data. So you can load the data from network. There's also a custom version where you can use OK HTTP if you don't want to use the basic Android HTTP. And there is asset data source if you have some file on your device. So if I show you a very simple ExoPlayer diagram, so you see that on this side, there's the renderers which talk with the Android framework. And on the other side, there are the extractor sample source. So basically, it just hides the media extractor. So you just have those classes on top of that. So it's like the video track renderer and audio track renderer require sample source, which should be injected in their constructors, and they require data source. So it's like a chain, which eventually you could get ExoPlayer instance and just insert the renderers in it, and it will play the media. So if I show you the flow in more detail, the one thing I want to mention is that audio is very important. We can, like as an app developer, as a user, we can like, if there is some buffering or some loss in video, we can, yes, sure, it's okay. But audio, yeah, we don't tolerate it. So audio should be handled first. So first, we get some audio. We read data. So these are just the buffering, like we do buffer input buffers, and we dequeue the output buffer, and then we handle the buffer, and then we do the same thing on video. So just the flow. I mean, it's so simple to use. So I will show you in the code also how it works. So let's just go to the code and see how it works. So yeah, I have, like they have a very good demo app. So I just used most of the code and made a very simple version of it. So here you can see there's a player activity, which basically has all the controls and everything. So I search for prepare player. So here I create a new instance of demo player class, and I will go inside here. So see, I create a new ExoPlayer instance, and it just gets the renderer counts, and then it gets the renderer. So the main thing is that where we build the renderers and everything, because renderers need sample source need data source. So I will show you how you make it. So we have this class extractor renderer builder here. So we'll just build the renderers here. So for example, I have audio. Sorry about the live templates. Yeah, it's just to make my life so simple. And then I have the extractor sample source. And then I have the data source. OK. And then I have the bandwidth manager. monitor. Okay, so this thing doesn't work. Yeah, Android Studio 2 provides shortcuts. Okay, so I made the audio track renderer, but I have to use the video track renderer also. And you see that it basically, I put this intentionally as like I have to fill by myself. So it requires sample source. This also requires sample source. And then you come here, it requires data source. Okay. So now we have to set up the renderers and put in the ExoPlayer instance. So I just do the renderers MP4. Yeah. So one render is missing. So I will create it here. Text for Chamak. Yeah, subtitles, very important. Yeah, okay. So I will come in here. I will do make install. Sorry. Yeah, I want to show how much time it takes for you. I basically, in our company, we use the makes scripts, like, and the bash shells for all these kind of things, so they don't need to do manually. Yeah, so I just have the MP4. So I have this video I want to play. Yeah. So this is from network, but it's just an MP4. You see there will be some buffering and not stable, and it doesn't change the quality. It's just an MP4 file. So next, we want to solve this problem and come to the adaptive protocols. So I will just stop it here. Let's go back to the slides. Okay, so I think the main topic of my talk should be adaptive media playbacks, or ABR. So we have, so the biggest advantage is that it's over HTTP. I mean, you just need an HTTP server and the contents, and you can provide to all the users and customers. And it accommodates the network changes. For example, in morning from my home, when I leave for work, in subway, maybe the network quality is not good. And then when I come out, it's 4G. Then when I reach to office, it's Wi-Fi. So it can accommodate all the network changes. And no special firewalls, proxies, or cache is required, because it's all HTTP. It's so simple. And it's efficient and cost effective. Yeah. So there is one example. If you see, like, it's the quality. For example, 200K is the bandwidth. This 1000K, 1 MB. This 3.4 MB. So you see that the video quality changes. But this, like, the ExoPlayer will not let you feel it. It will be all very seamless because of the standards we will look at later. And this is the time frame from 0 to 60 seconds. So let's look at some of the protocols. The first one is dynamic adaptive streaming over HTTP, made by MPEG. So yeah, but I think Microsoft and some other companies worked on it also. So they have a white paper for it. Next one is smooth streaming, made by Microsoft. And the third one is HTTP live streaming, which the ExoPlayer like hardly mentions because it's made by Apple. Yeah. So yeah, let's start with Dash. Dash basically standardized by MPEG in around 2012, and the first experiment was during the Olympics, when people want to watch all the live sports on their phones. And how it works, basically you have a MPD, media presentation description file, which basically describes the bandwidth available, codec available, and the type of the media. And then you have segments. So these segments are basically MP4 chunks on your server. And there's a Dash client, and this is HTTP server. So Dash client can be your browser also, and it can be your mobile also. So first of all, you deliver the MPD file, the manifest file, and the client parses it and then it just requests for more like files with the HTTP GET request. So it's that simple, but it's not very simple. Yeah, it's a lot of things are going on here. So if I go deep into the MPD file, so MPD file has periods. So I will show a sample right after that. Yeah, maybe I should show the sample. So this is one example of an MPD file. So this is a HD movie, and you see on the top there is one period. So this file, this has only one period, but it can be 2 or 3 also. And periods have adaptation sets with the IDs, and the adaptation sets have representations. So representation is something very important because it has different bandwidths. You can see like for different network, and it also have like audio, video, or text. So defines, and a representation, inside one representation there are segments. So segments is what we want. So it has the URL, for example, segment 1, 2. The first one is always initial to just like sync the decoders and everything. And I will show you more details here. So you see, you have to make it bigger. So we have period, then we have adaptation set. And in adaptation set, we have a representation. So you see bandwidth, this is 1.3 MB or something. And then we have another representation with different bandwidth, like that. And the type is like it supports this kind of codecs, and it can have a content protection, which I will show at the end of this talk. And this is the main thing we want, because it has the base URL of this file, and it has the index range, like the byte range, you can say, which you want to fetch from the network, and some time scale and those kind of information. So if I come back to the code, I think so. This diagram shows like more detail of it, and you can see that it's still the same. It's the renderer, sample source, and data source. The sample source has a load control for buffering. Sometimes like you have some like Netflix, it buffers the data. So that is very important. The ExoPlayer provides a default load control, but you can write your own. And then the chunk source is where basically you switch like the high bandwidth or low bandwidth. So for example, in case of video, it should be adaptive based on the network, Wi-Fi, cellular network, or 4G. But for audio, I told you, audio is always the priority. We don't want any buffering or any kind of interruption in audio. So audio is fixed, always fixed. And these like 2 are shown for audio and video both. And then one can be added for the text also. Text is either included in it, or it can be separate, like captions. So I'll just show you the code. So if we come in here, I will not write any code, but I will just show you like how it works. So you see this function, build renderers. So basically, I told you that, you see, I told you period, and it gets like all the like manifest files. So if I show you how that MPD file is parsed, so this is the parser. So if you go into the parser, it's all written in Java, and it basically parses the manifest file and gets all the information and provide to the to whatever module which needs it. And you come in here, it is almost same. You see there is, wait, I will show the video part. So there is video renderer. Video renderer requires sample source. So sample source is the chunk sample source. And then the sample source required data source. So data source is here. And for audio, it is same, and also for the text renderer. It's almost same. Basically, video and audio are default made in, but text render is one example. Like they custom you can make it. Like so, this text track render is one example for you guys to see how it is made. And in the same way, we set up everything, and now I will show you how it works. So we have some YouTube dash contents, because YouTube supports ExoPlayer and also the dash contents. So I want to show this one. So I think, and so you see that I was talking about different bandwidth. So you see that 3 megabit, 4 megabit, and 6 megabit. But it was selected for auto because we were using adaptive evaluator. So if I come in here and see the video size, so I think it started from 720, 576, because Wi-Fi is not very good here. But for example, I want to switch to a higher resolution. Let's see. So I just forced it, and you see that the resolution changed here and everything. But if I come back here, it will be very slow because, because the network of Wi-Fi is so slow here. So it's hardly moving and just buffering and so many things for app developers to do. And audio has, like if for example, your app wants to support Dolby, like the 5-channel stereo, you can have that information here. So the tracks, I talk about the tracks like video, audio, and text are tracks. But within tracks, we can say like, oh, different bandwidths. So they can also be like tracks. So I mean, the stream and tracks are alternatively used. So it is very slow, very, very slow. Yeah. Okay, let's go back to the slides. Okay, so next one is HLS, HTTP live streaming. That's the most popular one until now, used by all the major companies and like the major like providers. So how it works, it basically has this M3, what is that? M3U8, it's the extension file, index file, and it has the MPEG-2 TS files. The transport stream. It's not MPEG-4. It's just a special new format made by MPEG. And basically, you send the manifest file to the client first, and client parses it, and then requests for the TS files. So this is how an index file looks. So basically, you have these tags, extension X, version 3. So it's a version 3. And then you have so this ext INF, basically next to it, it's duration. So all the chunks are 10 seconds. All the TS files are 10 seconds. And you have the URL after that. So URL can be the full URL, also can be the relative URL. This is just a simple index file. But if I want to show you a more advanced one, so this is with different variants, because I told you that it should have information about different bandwidths, low bandwidths and high bandwidths. So you see this ext extreme INF. So this is basically, you see the bandwidth, the codec, MP4, MPEG-4, the audio codec, and then you have the resolution. And this one is audio. Sorry, this one is audio. And then you have some for video also, subtitles. So this is the first file got by the client, and then parse it, and it requests the server like based on the logic implemented. I told you this already, that index file can have different alternatives for different bandwidths, and all of them links to a TS file. So Apple has this tool from which you can make you can make these TS files. So I will just show you quickly. So So I just have in this this command, basically what it does is that it gets this MP4 file, and it creates TS files and also the index files. So you just run it. So basically it tells me that average bit rate is 12.56 megabit. And oh yeah, because the video was high quality, HD quality, so it created a but there's another command through which you can make your own custom bit rates. So if I want to show you where these files are, so you go here. So these are all the TS files. So these are all 10 seconds file. If I want to play one, yeah, I can play because that supports MPEG, but they're a little different. So you have this index file, which is very basic one. If I want to show here, yeah, okay. So you see that, oh, it just shows the sequence 1, 2, 3, 4, 5, 6, 7, 8, like that. Okay. Okay. So yeah, next one is the HLS ExoPlayer is very similar to the Dash and smooth streaming one. It basically used the HLS chunk source and the sample source, and I just added for video. So let's see how I can make it. So I've come in here and I have like this to do stuff. Okay, yeah, let me do. So I will make the ID3 is the metadata tag, and then I have video renderer, and then the HLS sample source, and it requires the HLS chunk source. Chunk source requires data source. Okay, like that. So come in here. Okay, so this requires the data source. It requires chunk source, and it requires the sample source. Okay, and here we can, the audio we can have, for example, if there is special audio, then we can have the render for it, or we can extract from the media itself. So if we come in here, so have audio renderer, just like, yeah, I just made a template, sorry. Yeah, okay, so you can see a load control I showed you before. So all the parameters I'm using are default one, but you can, yeah, make your own. And then the audio render HLS. If, for example, there is no audio inside, so we just get from the sample source. There is no special separate audio like the high definition. And then if I have the subtitles, because subtitles are very important for the video. So I have this, and then I have just the text renderer for the HLS. Yeah, it's just the default one. And then I just set up the renderers. Same, you see, I have, so I have the text. Just complaining about the text, sorry. Here should be text one. I have to replace with the, yeah, this one. Okay, so I'll just play it. And this is our last one. So yeah, I want to play the Apple master playlist, which they have a sample. Sorry, it's so boring. It's just like that. Yeah, there is nothing. Yeah, and as a developer, I test with this, and I get bored all the time. So the text is by default disabled, but you can enable like that. For example, Spanish. Yeah, it will come after some time. The network is so slow. So the video, you can see that it has different formats, like, yeah, the high resolution HD, ST, and the low levels also. So there is also, these protocols support the fallback. It's like when no video is coming, there will be just an audio. I mean, there is a lot of case I watch on Netflix. There's just audio coming and the video is just still. So these protocols support that also. Okay, so the customization, how can you customize it? Oh, sorry. So you can customize the track render. For example, text render is one of the customization. And you can have, for example, your own overlay on top of the video, the emoticons and whatever. And the extractor, you can make your own extractor for different like type of media. Currently, MPEG-4 and the MP4 and the H.264 are commonly used. And there is also one for WebM. You can have a format evaluator based on your own heuristics, machine learning. Netflix is using machine learning now, I think. Yeah, and YouTube is also, I think it's just for recommendation, not for that, but you can use that. And you can have your own data source, for example, using OK HTTP or whatever, kind of that. So one example of customization is that, for example, the first time users see a video, second time it loads faster. So there is a cache data source, which is one example. You can build that. But there are some limitations, like if, for example, the content is protected, so you have to take care of those kind of things. And then the last part of my talk is about the digital right management. It's like the about the DRM, like for your content protection. So there are four famous ones. Microsoft made the Play Ready. Google has the Widevine, which the shirt I'm wearing. Nobody know Widevine, but it's a Google company. Then Fairplay, made by Apple for HLS. And then Adobe has the Primetime. So Adobe also has a streaming protocol, adaptive play. It's called something, I forgot the name. So if I show you the demo, how it works. So right now it is just implemented for Dash. So if I come in here and I show you the the video. Okay, so if you see the video one, where is that? This one. Sorry, the video is here. There is a DRM session manager. You can search that. DRM. So this one, DRM session manager. So basically it handles all for you, but it actually has a callback. So if I want to see the callback, I just go in here. So this is the Widevine test media DRM callbacks. Basically, it does all for you. Like it provides a media crypto instance for decrypting the keys, and also request the keys and do the provisioning. It's little like advanced topic. I just want to skip and do quickly. So basically, this is the proxy server on the Google. So if you want to protect your contents, so you first get the key and then encrypt, and then you have to decrypt while playing that. So the information I want to show you is, for example, here is the YouTube one. So I don't have in the YouTube, but I think this one has the content protection. So you see, so this is the part which is used by the media DRM. It has some keys and those kind of things. So I told you about this already. Okay, so I'd just like to conclude. I just showed you very quickly because the ExoPlayer is very simple to use. Basically, my company, maybe there are 60 people working on the similar things, like 15 people in each team. So each part has so much work to do. But ExoPlayer, like the Google open source it, so they did all for you. As an application developer, you just have to use it. So start with the demo code. Demo code is little little overwhelming because it implements everything, but it's a good point for you to start. And it just shows you the website. Sorry. So this is like where you get all your like ExoPlayer and everything. So this demo extension, I couldn't show that, but basically it is also very useful because in here it uses a special codec, VP9, which is built using the NDK. So it is like more useful and uses a couple of other extensions like OK, HTTP also. So this I couldn't show you, but you can try in your home. And you can see all the issues here, everything. So basically you see that they closed like 1,021 issues. So that's a lot, yeah, in short time. Okay, so yeah, my presentation is almost going to end. Okay, so the applications using ExoPlayers are YouTube on the newer devices, the Movies app on Android. And I heard that this app also uses ExoPlayer. I think Naver made this, but I think more Korean companies are looking forward to use ExoPlayer. It's a very good alternative. So, yeah. And yeah, thank you very much. And so, yeah, the sample code is here. If you want to contact me, yeah, my email is here, my website is here. So, yeah, thank you very much. 감사합니다.